Hi, welcome back. We are at problem 5.12. Let's read the question. We have a life annuity due issued to somebody aged 55, and you're given the annuity pays an annual benefit of X through age 64. Okay. Beginning at age 65, the annuity pays 75% of X. Okay. The present value of this annuity is 250,000. Mortality is as per standard ultimate life table, and the interest rate is 5%. We are asked to calculate X. Now, take a look at the timeline. First, this is the payment pattern. We have X through 64. There you go, starting from 55 all the way to 64. And then 65 on, we have 0.75X. Okay. Okay, so you can see that when you look at the timeline, what I have chosen to do is, okay, I've chosen to write this as 0.75x all the way, okay? And then, okay, 0.75x all the way. So we can write this will be 0.75 plus 0.25 all the way up to here, okay? So what's the big idea here? We're just trying to work this in an efficient manner. So instead of x all the way up to 64 and then 0.75x starting at 65, I've placed 0.75x all the way starting at age 65. But remember that that's not enough. I need to add a 0.25x, okay, 0.25x for the first 10 years, okay, 0.25x. So 0.75 plus 0.25 is x. Okay, 0.75 plus 25 is x. Okay, good. So that's how I write this line here, right? 0.75x a dot dot 55, okay, plus 0.25x a dot dot 55 angle 10. And this is your expected present value, and they gave me the value as 250,000. So this thing should have been expected, I would think. Okay, expected present value is 250. Look up the values from the tables. Okay, if you look up values from the tables, you will get a dot dot 55, right? And then you'll see a dot dot 55 angle 10. All these values are given in the table. Plug those in and solve for x. Okay, solve for x and you'll get 17,793.94. Answer E. Good. Let's move, right? Next problem. Let's see what they're saying, yeah? Let's read the question, and then we'll pick our way through the solution. An insurer, right, issues a special 20 pay insurance policy. I know it's payment. I just read it as 20 pay insurance policy on somebody age 45 with the following benefits. A death benefit of 1,000 payable at the end of year of death, provided death occurs before 65. So here we have a term thingy, okay, the first part. The second part of the benefit, an annuity benefit that pays 2,500 at the start of each year, starting at age 65. Okay. So you're told that level annual premiums of P are paid at the beginning of each year. Premiums are calculated based on the equivalence principle. Mortality is as per our standard ultimate life table, and the interest rate is 5%. We are asked to find P. Okay, great. So we are looking at the uh, equivalence principle. Okay, and so we know that we have to write the expected present value of the premiums will be equal to the expected present value of your benefits. So basically you need to refer to quite a bit to your tables. So I've done the work there. You can look at the tables yourself instead of me reading off the tables here. So let's talk about the principles. Yeah. First off, we have the expected present value of the premium. That will be P A dot dot 45. That's the guy's age, right? Angle what? Good, 20. Yeah, because it's 20 pay. So look up the value in the tables and you'll get this. Okay. The expected present value of benefits. Well, first we have this thing about if the guy dies in, let's see, if the guy dies in 20 years, he's going to get $1,000. So I have this part of the benefit, 1,000. Okay, 1,000 A 45 term angle 20. And then we have an annuity benefit of 2,500. There you go, which starts 20 years later, right? Because he's 45 now. So 20 slash A dot dot 45. Sound good? Okay. So once you do that, right, the rest is trying to find the values of the insurance functions and so on. So let me show you. Okay. This part here, right? Remember we have your endowment. Okay. Endowment is your term plus pure endowment, right? So your term will be endowment minus your pure endowment. So this is your term thingy. So go and look up your tables to get your endowment value minus your pure endowment, right? Pure endowment is easy, which is VN NPX, or we've got NEX, right? These are all available in the tables. Okay, good. So you pick these values up, and then this part here is not so bad because this one here, we also have the same VN NPX here, as you can see. Okay, VN NPX here, and then move 20 years forward, it'll be A dot dot 65. Okay, it'll be A dot dot 65. Read up the value from the tables, clean this up, okay, and you equate it to what you found earlier. Okay, good. Okay, take this and you equate it to this, like I've done here for you, and you solve for P, you'll get 944.169. Correct response will be D. Okay, let's move on, right? So I can clear this. Next problem. Okay, our next problem will be (6.56). Let's read the question carefully. You'll be fine, yeah? 6.56, we are trying to find your annual gross premium for this policy. We have a fully discrete 20-year endowment insurance policy of 1 million, yeah? On somebody age 35, you're given all these facts. First year expenses are 55% of the premium plus 150, yeah? So 55% of the premium plus 150. As you can see, I've indicated it here. Okay, 0.55G, if I'm going to call the gross premium G. So here the expenses will be 0.55G plus 150. Okay, good. Then the following year, after the first year, expenses are 5% of the premium plus 50. Now, then you have your mortalities as per standard ultimate life table. Interest is 5%. Premiums are determined using the equivalence principle. Okay. And you also calculate the annual gross premium on this policy. So let me just clear this. Look at my first line, right? And you're basically done, right? If you look at my timeline here and my equivalence principle statement, the left-hand side is pretty straightforward, right? The expected present value of your future premiums. That'll be G A dot dot 35 angle 20. So that's no problem at all. Then on your right-hand side, you should have expected present value of future benefits. And remember that these benefits now we have, maybe I shouldn't write it like this. Let me add, right? Expected present value of future expenses. And in our class earlier, I told you that I just remember it as expected present value of future benefits, because benefits is money going out, and that will include your benefits plus your expenses. So now that we've dealt with that, this 0.55G, I like to write it as 0.5G plus 0.05G. This 150, I want to write it as 100 plus 50, so that I can write my annuity functions without any problem, right? So the expected present value of your future expenses. Let's take care of that first, yeah? Expected present value of future expenses. So there's a 0.5G, okay? And there's a 0.05G here. Let me just circle this. And then there's 100 and a 50, right? This is all from here, right? So I have 0.05G, 0.05G all the way, right? So I have 0.05G, A dot dot 35 angle 20, okay? Then we have a 150, I broke it up into 100 and into 100 bucks plus a 50 bucks. So I have 50 bucks all the way, right? So I'll get 50 A dot dot 35 angle 20, right? So I've taken care of these. The rest of it just plug in. So I have this not taken care of. There you go. Then I have this not taken care of. There you go. So I've taken care of this, I've taken care of this, I've taken care of this, I've taken care of this. All done. Okay. Now, after that, just worry about your expected present value of your future benefits. So that'll be 1 million times A 35 angle 20, because it is an endowment insurance policy. Yeah. Once you've got this line out of the way, then you just look up your tables. Okay, look up your tables and clean it up and solve for G. Yeah. And basically you're done. You'll get 32053.19. Your response is D. Good. So this is a pretty standard problem on gross premiums.